Why is it critical to understand the interaction between geology, topography, and climate in an environmental study like this? How do each of these factors individually and collectively contribute to the chemical, physical, and biological processes that control the movement and accumulation of sodium and other salts in the landscape? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the elevation gradient influence not only environmental conditions but also land use patterns? Are lower-lying areas more likely to be used for agriculture and therefore more exposed to irrigation-related salinization, while higher zones remain forested or undeveloped, thus experiencing different salinity dynamics? How can the spatial variation in rainfall and elevation across the 540.61 square kilometers study area be accounted for in the research design? Should sampling sites be distributed across different elevations, slopes, and land cover types to fully capture the range of conditions present? And how does this improve the accuracy and representativeness of the conclusions drawn about salinity and acidity in Tierra Nueva? How do topographic features like Cerro La Silva and Mesa de Salsipudes influence wind patterns, water drainage, and microclimatic conditions? Do they create shadow zones or catchment areas that alter soil moisture retention, mineral weathering, or vegetation health in ways relevant to sodium accumulation? What role do surface and subsurface hydrological processes play in such a complex terrain? Does water tend to collect in lower areas, bringing dissolved salts from higher elevations? And how does this vertical and lateral water movement shape the patterns of soil degradation observed in the study? How might this detailed geographic, geologic, and climatic information be used in conjunction with salinity data to create predictive models or vulnerability maps? Can researchers integrate spatial layers in a GIS environment to determine which areas are most at risk for future salinization under current and projected environmental pressures? How does this specific environmental setting compare to other arid or semi-arid agricultural valleys around the world? Are there universal mechanisms of salinization that apply broadly, or does the unique combination of elevation, rock type, and evaporation in Tierra Nueva produce locally specific challenges and solutions for sustainable land management? What different methodologies are used to investigate the source and nature of sodium salinization in soil and water systems? And why is it necessary to use a combination of methods rather than relying on a single approach? Does each method contribute a unique type of data or insight, and how do they complement each other in building a comprehensive understanding of geochemical and environmental processes?